Question 3. Well, this is really just about getting your right-angled triangles drawn appropriately, because if you can, it's then very straightforward trig in Pythagoras. So, for part 1, we've told that we've got two forces of magnitude 8 and 12 newtons acting at a point 0, and that they are perpendicular to each other. So really what we've got here is a 12 along and an 8 down operating from 0, but the net effect is best viewed if we just move this force to the right along to here. So we say our net effect is a 12 to the right and 8 down, so that's our resultant force, that diagonal. So bearing that in mind, we're being asked to work out the angle between the resultant, there's the resultant force, and the 12 Newton force, so this angle here. So we've got an opposite of 8 and adjacent to 12, so tan theta is 8 over 12, theta is 33.7 degrees. Now the magnitude of the resultant, that's the size, the length of this resultant force, so clearly this is Pythagoras, so r squared equals 12 squared plus 8 squared, r equals 14.4. Now for part 2, it's just a slight change. Now we're being told that we've got an 8 upwards and a resultant force of r being a horizontal force, and therefore our 12 newtons is the diagonal force. So just rearranging this, we've got this. So we've got an 8 up, a 12 diagonal equaling a resultant force, a net effect of 8 up, 12 across, a net effect of a horizontal force, resultant force of r. So now we're being asked to calculate the angle between the resultant force and the 12 force, this angle here. So we've got opposite over hypotenuse, so sin alpha equals 8 over 12, alpha equals 41.8 degrees, and now on this occasion we're working out the length of one of the shorter sides. 12 is the hypotenuse, so r squared equals 12 squared, take away 8 squared, r equals 8.94 newtons.